My name is Dave Buschman. I'm the technical lead for a small dark startup called Timeli.io. My talk is going to be on schema upgrades in a continuous delivery environment. So some people ask me what technical lead actually means. Right now, it means leader, architect, coder, CI, CD, and DevOps, and that's on a good day. All other duties assigned also pretty much applies. Here, since we're at a Reactive summit, give some Reactive credentials for what we've done. I started in August of 2015 with this startup. It was kind of reformed as a startup. They purchased an existing piece of software, and we began migrating it from a legacy Java Enterprise app over to microservices and Reactive. Take a look at some of the technologies that are involved. Some of the key stuff, we are now all using reactive streams, namely Akka streams. Kafka is our main data in motion. We also migrated off of a MySQL/Percona cluster, which was having performance problems, onto MongoDB, and Cassandra holds all of our heavy time series data. So we also were forced to do a migration between Google Cloud Platform and Amazon, and we decided Docker at the same time. So a couple important points about this. The existing system that I inherited, basically under thousands of measurements per second, would actually be very stressed. But in our new system, because we are reactive and scalable, we load test regularly at 1 million measurements per second. And that's a low watermark for getting enough performance out of the system to get measurements that are actually useful for helping us figure out how to scale this thing. Steve Jobs has been quoted in several different forms, so I'll just kind of paraphrase it, in that a small group of A developers can outcode a larger team of B and C grade developers. You know, there's some form of that because the internet has many forms of it. But for us, in 1 year with 2.5 Scala developers, we did a lot better than 6+ developers over at least 6 to 8 years. The version history only goes back to 2012 when they did a straight copy from CVS to SVN, and there's no history out of CVS. So I don't know how far back it goes. So that's just a little bit of where we're at. So how did we get here? In the past, I came from a Java Enterprise world, so this is what we basically did. We had long development cycles and releases. We had complex testing, if any, on older products. I've deployed production products to production that have actually no tests. Anybody willing to raise their hand for doing the same? Yeah, maybe. So at one company, we even used a down page to block requests and basically warn customers about how much we sucked because we couldn't keep our app actually running. We take the database offline, we back it up, we upgrade it, we install the new application code, and then where everyone actually starts is we start everything back up and start praying for no rollback. In many ways, the praying even took on various forms of mantras and other things, kind of resembling a lot of baseball players and their weird behaviors. A colleague of mine actually described it probably best, and it's like throwing mashed potatoes on the wall and hoping it sticks. And really hoping it actually sticks. So, what's wrong with this approach? Well, too many things are changing at once. We are modifying the code and data stores at the same time. So we get this chicken and the egg, cart and the horse, cart before the horse, before the cart, before the horse type scenario. We have stored procedures, which from my opinion is the wrong place to store business logic and causes a lot of serious problems with actually trying to manage risk in the system. And because of that, we incur higher risks due to increased chances of rollbacks and the cost of management confidence. Probably one of the most overlooked thing by developers is when management loses confidence in your ability to deploy software, they get involved and the process only gets worse, and sometimes really worse. I've actually ran into a scenario where it took us over a year to deploy a major version of software into the code base. And some of the code that had been developed was over 18 months old before it actually went into production. So because of no confidence by management. And in many ways, you are your own self-inflicted chaos monkey. So I'm going to assume in this group, everybody knows what the chaos monkey is and the simian army and all that. So with every good wrong approach, we need a way to guide us out of this. So I have a trilogy of topics to guide us, and everyone knows that a good trilogy actually has 5 parts. So, continuous delivery. We're going to leverage continuous delivery for fast and reliable changes because we want to get there. We're going to talk about a guideline for deploying the changes and kind of some hard-won rules that I discovered as I was doing this migration of all three, the MySQL, the Cassandra, and the Mongo data stores, and how to actually make those changes actually happen in the system. We're going to talk a special note about relational databases and the limitations and problems, additional problems and limitations that come from dealing with relational databases. And the rules for validating each step in an upgrade saga. This actually is a form of a saga pattern, and we'll talk a little bit more about that here in some slides coming up. And of course, rule number 5 is don't panic because you brought your towel. So let's start with step number 1, continuous delivery for fast and reliable changes. One of the things we can leverage is our deployment iterations are now in hours and not weeks, months, or years. And we're going to leverage that fact that we can deploy more than once in a single day. You may not want to, you may want to limit to one day, but you can deploy more than once in a single day and not just once a year, like that. Automated builds and testing to validate non-breaking changes. I'm assuming everybody here, if you're doing anything close to continuous delivery and continuous integration, you have automated test suites that prove your software out. If you don't, you need to get there first, for sure. So fast deploys force updates to be small. This actually reduces our risk, and it's very important to kind of key on that, in that we're not going to be updating a lot at any one given time. And of course, I would be remiss without talking about revision control. Applications as code, using the add code moniker is kind of, we've been doing that for decades. That's version control. Infrastructure as code is something new that's coming and is definitely something you want to look at and, basically organize so that all of your infrastructure changes have to be committed. This might actually not be in a Git type repository, but it may be in an orchestration software like Mesos or Marathon or Kubernetes or any of those others. They actually are storing what the configuration of your infrastructure actually is. And I want to add one more to that list, and that is schema changes as code. This is, if you're in a relational database land, probably where your DBA is going to actually start complaining. Because they have had a free reign of the system and been able to modify, tweak, and fix problems without, at any point in time in the system. And wrangling control of that is actually something that might be a challenge for your organization. In my case, I happen to be the DBA and the DevOps and the application developer, so it was just me, myself, and I arguing with what we're going to do. And in many ways, today, I just make a pitch out to version control everything. We have very good tools for doing that, so definitely take a look at that. So, number 2, guidelines for deploying changes. These are some of the hardest fought rules and phrases that I came up with from basically a lot of mistakes or problems and things, because the main thing we wanted to do is we wanted to actually do schema upgrades, but we can't take our service down. We need to change the data store, but we got to keep providing requests to the users, either our own internal users or the public API in and of itself. So how do we actually do that? So here's the rules that I've come up with so far to help me actually get through this process. And that is we're going to deploy only one small change at a time. That means we're only going to do a schema upgrade. We're not going to deploy new code or any new features or anything else in this microservice. We're just going to deploy the one small change. And because we're doing continuous deployment, we can just leverage that fact. We're going to execute this thing as a sequence of small steps, AKA the saga pattern. And we'll talk about that a little bit more in a little bit. But it is a long-running, kind of the effect of a long-running transaction. We're only going to change the code or data store at one time, not both. This alleviates the chicken and the egg or the cart before the horse problem that you're going to run into quite a bit. And having said that, if you are using ORM frameworks and DDL in relational database, you technically have a dry violation. You have one copy of your schema or source of truth in your primary domain language, and you have another in DDL. And so because you have both of these, you might have to actually change these at the same time to keep these compatible, especially ORM layers. And it really depends on what your ORM is and how you have it configured as to how painful this might be. So I can't really answer all details because your mileage will vary from everyone else's mileage, depending on that. Specifically, if you have schema validation, set up so that, in Hibernate, you're actually validating that your domain in your databases, your domain model and your DDL are matching, you might need to turn that off during the course of an upgrade, because you need to keep the application running without doing its validation against that. And we'll see that here in a little bit. Another thing about relational is store procedures. Store procedures immediately violate number 3, which is only change application or code or data store, because they are application code in your data store. So by definition, you're modifying both at the same time. If you have to deal with store procedures, each one of those, walk carefully. There are ways of doing that, but and I'll give you some help guidelines in a book reference, but each one of those ends up being a one-off that you kind of have to basically hand-hold through the actual system. If you aren't dealing with store procedures and you're free of relational databases, things get a little bit easier. So in Cassandra, Mongo, and the key value stores, as well as graph databases, which we want to use. So for data stores, the other thing we do is we always update asynchronously. I know some people, in some places I've also been, where we use Flyway, and we actually stopped the application from booting, did all the Flyway upgrades, and then continued to stand up the Java Enterprise app. And in this case, you can't do that. If the app is going to come up, it needs to come up immediately, and then you do all your schema upgrades after the fact, or in asynchronous. If you're in Scala, throw it in the future. If you have Akka around, throw it in an actor that sends itself its own poison pill when it's done. And so very important to actually not hold the system up for doing that, because your application needs to serve requests, and you're not going to stop to get this actually done. So one of the things we're going to do is we're going to work very hard not to be our own chaos monkey. And that has been probably the biggest challenge of all, of trying to actually do this without actually causing downtime. And it can be done. So there are 2 approaches to delivering changes. For the data store, we obviously know how to deploy code changes, but specifically for data store related changes, there are 2 approaches you can do. You can actually run inside your app as an asynchronous process, usually upon startup, fire up a thread, fire up an actor, whatever you want to do. And you can do that if your microservice is small, but key note, if you're actually doing rolling upgrades, you're going to have enterprise lock type scenarios if you try to do rolling upgrades of more than one service at a time. So if you've got 100 services and you're bringing 3 or 4, maybe 5 down at once to do a rolling upgrade, all 5 of those when they come up might try to actually run the same upgrade. So you got to make sure they don't have contention. If you run into that scenario, I'd not recommend doing this. If you have a small number of services where you only rolling upgrade one at a time, you could probably get away with this. But a better way to go is, of course, 12-factor apps. How many people are familiar or even doing 12-factor app standards? So does anybody know which one of the 12 factors applies here? Nope. Okay, it's number 12. So it's run admin or management tasks as one-off processes. So in this case, what you do is you actually just have your own little micro app, which actually just runs once and then dies. It performs whatever upgrade you need to do, changing the data in the database. It might run for a very short period of time. It might run for long periods of time, especially when you're making migrating changes to Cassandra. Sometimes you actually need to monitor that as a more long, even though it only runs once, it runs for days at times. And so this is the kind of the better approach, I think, to run. The easiest thing I do is usually I'll grab the microservice that actually uses that data store, and I'll create a branch, I'll gut it, and take all the business logic out, so it's just the configuration and stand-up, and then I'll literally just hack the code right there of, okay, what are you going to do, how are you going to query, what updates are you going to perform to the database, and then just have it exit when it's done. And so all the configuration, the stand-up, and the service discovery stuff all works because it's an existing app. Deploy that in a special container, and then just run that once. So that's a pattern that I found that works pretty well. So number 3, a special note about relational databases. If you're dealing with relational databases and doing a lot of refactoring to your relational databases, which some people are scared to do that, but for me, I was basically, I don't know if hell-bent, but I was definitely determined to actually get off of the relational issues and the performance we were having with our relational database. So I got very aggressive about dealing with stuff. And this book, Refactoring Databases, is well over a decade old, but it's still probably the best hacks and special circumstances and how you can get around things, basically by adding store procedures and triggers and custom events to make the database look like it's not really, but just But you make it behave in a way that allows you to perform an upgrade and change the system out. And then you later can remove the triggers and stuff like that. So if you're doing relational, definitely check out this book. So a few rules. Since we have a saga pattern and we're doing a bunch of sequence of steps, we have some rules that I've come up with that helps me validate that each step is in fact accurate and not too much, not too little. And so let's go through these 4. Each step must be backwards compatible to the previous step. Each step must have verifiable accuracy. Each step must be small and easy to implement. And each step must have a simple backout or recovery plan. So in many ways, the interesting thing is when you go to describe your backout and recovery plan, the interesting thing is if you have trouble doing that, it tells you that 1 and 3 are not correct. If you can describe your backout plan very easily, then you know 1 and 3 are probably okay. So that's just been some history of what I've learned from that. So, and that's where 4 actually came from, is trying to really reason about our backup plan, if we have one. So, and step number 5 is, of course, don't panic. So let's think about this scenario. The top, ignore the colors for now. The top is a set of applications that are sharing a data store. This could very well be your legacy Java Enterprise monolith actually talking to a single data store, but you're going to have trouble, probably more trouble changing it. In many ways, this represents a set of microservices or many instances of the same microservice talking to the same data store. The bottom one is, again, many microservices, each having their own replica. Both of these scenarios can be handled with the rules that I've come up with, but in this case, we're going to actually talk about the top one, which is the more complicated case. Because let's take a look at the colors. You're performing a rolling upgrade, and let's say you're halfway in between. So what appears to be, I believe, white boxes, even though they're light blue, are version 1 of your application, and you've started a rolling upgrade, and now you're doing version 2 of your application. And so version 2 are the dark blue. So you're halfway through, but you've already upgraded your schema. So you have to make sure in this scenario that both the version 1 apps and the version 2 apps can handle what the change in the database is. And that's where some of the tricks come in. And that's where we'll see where by going through a series of steps, we can actually roll this database where we can actually keep the apps running, keep servicing things, and both the old and new apps can actually handle the changes that are happening to the database. So, let's see, yes. So let's go through the example that we're going to talk about. The example schema we're going to talk about is this. We're going to replace our legacy crypto library for all OAuth client secrets in the database for each of our tenants. If you know OAuth, there's always a secret that they hand to you prior, and you basically match on that and verify that it's correct. Well, the crypto that was actually put in place was quite old, and by today's standards is hackable on a minor set of GPUs in a matter of days to a week. Without giving away exactly what the algorithm was. We needed something a little bit better, so I wanted to replace it all. So we're going to apply all this new crypto to all existing tenants, as well as new ones that are being created, and new ones can be created as we're actually doing this rolling upgrade, although not likely in this case. But data can change on you while you're actually doing this. We're going to remove the old data when complete, and for relational database people, this might mean deleting a column, which may or may not be a problem for you. This will take 6 steps to complete, and in many ways, this is the form of a saga pattern. So let's look at it with a sequence diagram as it might look. In the saga pattern we're talking about, there's 2 kind of definitions that flow around there. In the CQRS land, it's long-running process management used to describe that saga, and in XA, it's a failure management handling of the distributed transaction, if you can actually get that to work. So here's a semi-sequence diagram that I kind of had to hack a little bit to fit on the screen so you guys can actually read what was on the screen. So for each of the sagas to the steps, there is a return step and some time spent, but I had to delete all that so you could read it. So it was just too large for the screen to make the screen readable. So step 1 we're going to do is we're going to create a new column in the database and or field, and we'll talk about the complexity of step 1. Step 2 is a code change. That's what the C and parens are. We're going to implement the new crypto algorithm. Step 3 is a database change where we encrypt all the secrets. Step 4 is a removal of the field. That would be the old field in the code. Step 5 is the removal of the column in the database, and step 6 is removal of the old crypto jar. That's just a cleanup. Don't leave legacy crap in your application for the developer that comes 6 months behind you going, why is this code here? So, especially since I'm usually that guy coming back. So let's start with the details of each of these steps. So in step 1, which could be a database or a code change depending on which data store you have, if it's a relational store, you might have to actually split this into 2 steps. If it's not a relational store, you can do this all in 1 step. And that is this. So each one of these slides will have a before and an after segment. And so in before, if you read the top line, it's all the reads are going to go to the old column, which we're implying a new column, and all the writes come from the old column, or go to the old column. So, and then inside the box, the top line is a case class, where we're basically just represents the domain model. It doesn't have to be Scala in this case, which it happens to be just because it's really concise, but it represents that there is an ID and there is a client secret, and both of them are populated. Neither of them are null. In Scala, a string in a case class is a required field. If you want it to actually be optional, you need to actually wrap it in an option, for those that don't know Scala. The bottom is JSON, which represents your database rows, and it represents the pattern, not each individual row, but the patterns or types of rows and what columns are populated. That's why the values are dots, because you don't really care what they are. You just care about the pattern that you're looking at. And in this case, all of the rows in our database have an ID, and all of the rows in our database have a client secret. Now, there are obviously more both columns and attributes in our domain object, but I've left them out because we don't care about them in this scenario. There's many fields in this particular tenant class. So let's look at, after we're done with this particular step, what we want both the database and the domain to actually look like. And that in our tenant class, we have taken client secret and we have made it optional. Read for relational people, that's nullable. The column is now nullable. We're going to create a new column called secret that is also nullable and can have no value. And we're going to change the accessor from client secret to get secret, which is really just a little bit of handling for us. We're going to take it out eventually, but this is a little bit of a short-term hack to get us where we want to go. For those that don't read Scala, the get secret, client secret space get is just a way of actually pulling a value out of an option. So just ignore that if you don't know Scala. If you do, you know why you actually do that. And if you notice the database, we're not making any changes. We're not going to actually populate anything in the database, so we still have the same pattern in the data. There's only one type of data. There's no data in the new column. So we complete that whole process and finalize the rolling upgrade as a single step. So let's look at our 4 rules. For compatibility, no data is lost because the new column is not in play. We're just trying to get it into the domain model or into the database, or both. If you have an ORM framework, obviously you're going to have to play some magic with how you get it into the database and get it and have your ORM layer happy with it, either in the database or there. So depending on which one you have, you might have to play one goes before the other. So this might split into 2 tasks. Accuracy, you obviously have unit tests on your domain object. The code change is very, very simple. You're looking at most of it right there. And back out, we simply restore the domain object to the before case. Because no data has changed, we're just putting code in that's not available. But the key is we're going to roll this code all the way through, so every service, every instance of our service actually has the definition of both columns. And that's kind of key. That it doesn't matter now, but it will matter in the next few steps. So in this case, it's kind of like, I talk about being backward compatible, but in many ways, you also need to be forward one compatible. And that's where it kind of gets, if you start thinking about that, you always need to make sure your next step is compatible with what you're doing now. And so this is rolling out a change that allows us to do the next few steps. And we're going to always make sure we know what the next step is. So let's look at after we've rolled this all out, we know what both our domain and our database look like. So let's go to the actual meat of the thing, which is step 2, and that is implementing the new crypto algorithm. So our before case is the same as we had at the bottom. And so here's what the new case, or after we're done with this step, what it's going to look like. All reads are going to grab the new value, then the old value. All writes are going to write to the old and the new. So we're actually going to be writing both cryptos. If you're in a non-reactive, non-asynchronous future type land, this might actually incur a performance penalty. But in general, if we're doing all this in Scala, so we just actually sequence up futures and do both cryptos at the same time. So, and in our case, the new crypto is actually significantly slower than the old crypto. But that is actually by design. It takes almost half a second for the new crypto to actually run. So, but in some ways, a little sidebar on crypto. If it takes half a second to actually encrypt, it also takes a whole lot longer to actually brute force hack it. Like the new algorithm we're using is on the with GPU farms is on the order of thousands of years, whereas the old algorithm is on the order of it could be brute force hacked in weeks, and a few, like under 2. And so in this particular case, the key to the whole thing is now the get secret method, notice, got a little bit more complicated. We're going to read from the new field. If that field is null, we're going to read from the old field and grab the value. But we know that one of those two is present. If you look at the domain model at the bottom, you notice we now have 2 patterns in the database. One where all client secrets, the record only has a client secret, and a new pattern where we have both a client secret and a secret. And this is important, that once we finish this task, because we have both values populated, that allows us to actually come back and actually start removing the code. So now what we're doing now is going to help us 2 steps in the future. And so let's go through our rules. Compatibility, well, no data is lost. Both columns are in play, so we're not dropping any data. So both the old code and the new code can actually run against things. Test the domain object and domain updates. We have it's a small code change. You're looking at most of it right there, plus the encryption code, which is off screen. And a backout, we simply restore the domain model to the before. We just ignore all the new code we've done. So I'm going to go back real quick and take a look and kind of help you understand the before and after. So if you look at the domain model for the bottom box, and you look at the code for the top box, you realize that all of the applications that haven't been upgraded still will read the old client secret correctly. They'll ignore the new secret, but at least they return the old secret. But if any writes come in on the new app, it's going to write to the new end of the old. So the new app's covering literally, the butt of the old app. And so it's making sure that what it does isn't going to break the old version of the application. And that's critical. So that as you're doing the rolling, because a rolling upgrade can take an hour or more, depending on how many you have and how many minutes you actually wait in between each set of servers coming down to verify that things are still stable. So that's key and important. So we've finished that upgrade, and then we have both columns in play. So now we're going to go back through and encrypt all secrets. And so what we're going to do is we're going to write a schema upgrade to re-encrypt all secrets. This is where the micro one and done app comes. If the upgrade is simple, you could actually get away with just running an update statement. If you're a little ballsy, you can run an update statement directly on the database. But generally, I like to actually run it in code so that I can test it I can verify it works in test, actually run it through our CD build and integration test, and actually have it actually show me that it ran there too before it actually pushes out to production. So the steps are this. We're going to get all tenant data where the secret column, that's the old column, is empty. The new column is empty. We're going to decrypt the client secret and re-encrypt it using the new algorithm. And we're going to update all the new values where the secret column is still empty. And this is key. When we're going to put the new value back in, we want to make sure the new value hasn't already been written by somebody that's already upgraded. If they've already upgraded, that means the value is different than the one we read. Might be, might be not, we don't know. So you need to make sure that your where clause includes where the column you're going to write into is still empty. So, and hopefully, most data stores actually have per document or per row asset compliance type stuff and maintainability or integrity there. So let's take a look at what the database is going to look like after we're done. Basically, we're back to one pattern, but for the domain model, both client secret and secret are populated in all cases. So, and the domain model doesn't change because this is either a one and done app or it's a query that you do directly on the data store. So compatibility, no data is lost. The new column is now populated. Accuracy, we query the database by hand just to verify there are no rows or documents or whatever your terminology is for your data store has no data missing. And it's pretty easy. It's simple. It's just the code to populate a new column, and most of the time you're going to throw that code away after you're done. And to back out, there's really none because step 2 worked. Step 3 is just a fully population of what you didn't complete in step 2. And so We complete that, which if you're doing it in a one and done app, it's not even a rolling upgrade. You literally just deploy a container, watch it run, verify it, and kill it, and take it out of the system again. So your app actually stays running. So step 4, we're going to actually remove the field. Now we've got the full data populated. Now we're going to take stuff out. And so our before case is pretty much the same as step 2. And also through step 3. So after, we're going to take everything back down to what the new model is going to look like, and we just have the secret column. It's back to nullable. If you're in a relational database, this might get interesting of trying to actually take a column from not null to nullable. You have to, again, your database may allow you to do that, may not, in some cases, or do it successfully. The get secret method is now gone. We just use that as a temporary because we can just rewrite everything to use the secret getter. If you're in Java, you may have just overloaded the actual getter that was already there because you have to write one. In Scala with case classes, it'll generate one for you, so it does change a little bit. And specifically, I use the get secret or the Java version because it really makes me want to remove it. I don't want to see it in there, so by putting it in there temporarily, it encourages me to get rid of it very quickly. So when we're done, we basically have 2 different domain models. Or domain patterns in the database, and that is we have some rows that have both client secret and secret populated. We have some rows that have just ID and just secret populated. And if you notice, go take the domain from the bottom and look at the database from the bottom and look at the domain object on the top. The get secret method, so half of our methods are still using this old method. They will get the secret first, which is always populated by the new app. So they're always going to get the new value and return that for comparison on crypto. And if they don't have it, it will get the client secret, but that code really doesn't apply anymore. So the old code and the new code will actually return the correct value, which is the new encrypted secret at this point. So we've successfully migrated the entire microservice over to using the new column. And at this point, as soon as we roll it out, we only have a couple more steps to do some cleanup. So for going through our rules, compatibility, no data is lost because the new column is now in play. Again, unit tests for accuracy. That's almost always the case for accuracy these days. Small code change because most of what you're seeing is on the screen. And the back out, we simply restore the domain object to the before case because the before case still actually can work. It works for both objects. So we complete that rolling upgrade, and we have step 5. We're going to actually remove the old data from the database. This actually could just be a delete statement. In Mongo, you're doing an unset on a column. It's pretty simple. It doesn't even have to be a code change. If you want to do it in an application, you can do another one and done app. If you're in a relational, it might be, it'll be an alter table statement of some form, depending on what your database actually allows, what your vendor allows to actually do as far as dropping columns, or the data out of the column. And so the before case is pretty much the same. After we're done, the database now does not have a client secret column. So the client secret column was effectively removed from the database and from the code. And we're pretty much done, but let's go through our rules. So compatibility, the only data that is not used is removed because it was no longer in play. Accuracy, only data that are removed is verified to be stale. We know we're actually not using it by looking at the getters that are involved to get that data. And it's simple, just the code to clean out the old column, which may not even be code. It may just be an expression, a SQL statement, or a database query, an update statement. And our backout, really there's none needed. We're just cleaning up the data. So if it doesn't completely work, we just keep going until we got it all. Just don't delete data that you actually need. So, and we got one final step just because we're good custodians of our code base, and that we're going to delete the old crypto code. We're going to remove the old library from the system. Really has nothing to do with the domain nor the actual database. It's really just getting some stuff out of your deploy, out of your artifact that you're deploying. So you're removing code that's not active. It's a very small code change. The unit tests on the domain objects haven't really changed, so they should still work. And there's really no need to back out anything because it's all code that shouldn't have been there in the first place and is not really used. And so this is also, we talked about ORM to DDL validation. If you had to disable DDL, your validation on your schema, this is where you're going to want to reactivate it and put it back on because now the domain and your database are now back in sync. And so now you can reactivate that and put yourself back under that protection umbrella. So, and we're done. We're done with that pattern. We've successfully rolled the database, changed a column out, and they kept the microservice running and supporting our customers, even if we did rolling upgrades on it. So, any questions? That is my talk. Is there a hand back there? I can't quite see. I think I heard that as a relational constraint. Okay. Yes, you may have to look at, that's where the book comes in of how you actually, you're going to have to relax the constraint, like remove it, but then you can put a trigger in to kind of make sure it's still there unless it's not supposed to be. So that's actually part of that book where there's all kinds of tricks you play when you're forced to be in a relational database and the limitations there. So definitely read that book. They've got tricks for how you do that. So, and I just literally, I followed their tricks, pretty much blindly because they already figured out how to do it. So, I don't know which one. You guys pick.
You mentioned version control. Always do version control. How are you using your version control system, in this case, between releases? Are you committing everything straight to master? Are you making branches?
Well, yeah, our system, we use a form of Git Flow where we're using feature branches and we commit back to develop, and then develop is pushed to master. And master does the CD process. Well, develop does a CD process. Develop goes all the way through CI and integration tests, and master actually does the deploy to production.
This was like 6 steps.
Yes.
Merge master.
Yep, but we're only merging small changes. And in some cases, the one exception to that rule is the one-off app that I do. That doesn't actually go through the entire CI/CD process. I merge it into develop, and I make sure it goes through the thing, but then I actually go grab the Docker container that it generated, and I just manually push it and run it in production. I handhold that through the process because there is no automated way to push a one-off application into our system. And it's easier just to literally go say, hey, push it into the Docker, the production Docker registry, and then go into, in this case, we're using Rancher, sometimes on Cattle and sometimes on Kubernetes, to just say, hey, here's a container, go run it. And show me the logs for when it runs. And because it's running in the right environment, it picks up the service discovery and our console config, and just figures out where it needs to connect to, does its upgrade, and then stops. And I literally just look at the logs. When I'm done, I just click on remove container. And I'm done. And then I have not actually been all that great about removing those containers from the Docker repository, but I'm trying. There's a few turds left out there that I noticed for little one-off containers that are getting over 6 months old. So, but they're each uniquely named, and so it's pretty easy to find them. So, does that help? Yeah, but yes, all schema upgrades go through, in this case, Git. For our repository, we're on Bitbucket. So, using Git repository. So I commit all those changes, and I will, even if it's a schema upgrade, I'll write it in the terms of a driver. So whether it's a Cassandra, Mongo, or MySQL, I'll actually perform the upgrade using the code just so I know that it actually gets committed and we know what's actually there. So, yes?
Might be a slightly artificial question, but on the other hand, it may be representative of a class I can't decide at the moment. What if the upgrade to the database is something that changes the semantics in a way that the before and the after semantics are really can't be present in the database at the same time? So for instance, supposing you're dependent on the ordering of an index and the nature of the change is the modification to the ordering semantics of the index.
So if you're talking about the ordering semantics of an index, my guess is you're talking relational database. At which point, yeah. Well, in Mongo we use UUIDs, so there is no ordering to the index. You use another key to actually perform any indexes. So the only one I know of is relational, where you'd have that scenario, and frankly, I don't know how to change an index, a primary key index in a relational database. Usually that means a brand new table, and you got to copy all the data across. If that's the case, you might have to do that. You might actually, sometimes, I didn't talk about the migration side of this, because we migrated data tables from MySQL in a JPA form, and because JPA, some of the developers really didn't like JPA or thought it was too hard, they actually started writing tables in Cassandra. So they ran 10 record Cassandra tables, tables that have 10 records in them in Cassandra, and we're running on a 10-node cluster or 12-node cluster. And it was like, we actually played a game for 2 days of guess which Cassandra nodes actually have data for this table. And we started a betting pool. So the scary thing is no one won. We didn't realize the primary key wasn't leveled and they were all on 1. Okay, so I actually migrated some of the data from Cassandra back into Mongo where it should be, Cassandra is where our time series is, all of our metadata state is actually in Mongo. So when we did that migration, sometimes you have to actually step up a layer and create 2 domain objects, in your case, one for the new and one for the old, and maybe you figure out, okay, if I query the new and it has data, I'll go with that, otherwise I'll go to the old. That's more of a bridge adapter pattern, and I've done that in Spring for doing database migration stuff, which is on top of the schema upgrade stuff. Yeah. Is there one over?
Hey, I think it was implied by what you were saying, but I think probably worth being explicit.
Mm-hmm.
Because I've seen people get train wrecked before by not doing like adequate discovery of like what are these changes going to actually do. So everybody like walks in with preconceptions about the shape of the data is going to be like this. I'm going to run this function, and the outcome will be that.
Mm-hmm.
But I've literally seen people make like casing errors where if the string is exactly like this, then do X, and then there's a letter of a different case. So they wipe out records.
Yes, all of that discovery.
Sorry, go ahead.
Yeah, all of that discovery about what needs to change is outside of this process. This is just, I know what needs to change. Now I'm figuring out how to do it without stopping the app and without killing the app, or really preventing, and the biggest problems here were preventing our Hibernate JPA implementation from not coming up, because it would blow up on something when we tried to do too much at a time changing. And so it was literally, how can I baby Hibernate through this system to make these upgrades? Because I had to make changes to my SQL to prep it for going into Mongo. Namely, the biggest thing was every row in the system had to gain a UUID, which was a second primary key, because that would be the primary key when we went to Mongo. So we did that migration too. But I kind of stayed away from that because that's a talk, that's almost a conference in and of itself, as difficult as that is. So any more? Yes?
Two questions. Does your methodology allow you to roll back multiple steps rolling back?
No, you don't. Yes, because if you should validate that step is good before you move on to the next one. And that's where I say, because you do continuous delivery, you can do more than one change in a day, but there's that wait time, even after the rolling upgrade's done. Hey, production, prove to me you're stable, prove to me you're happy. And so you're gonna actually say, no, we don't need to roll back. Then you can start the next step. Now, you can code it. I've actually had all the steps actually ready to go, just literally push branch, push branch, push branch. And because I had it all figured out and actually ran it in my own, basically on my laptop. But yeah, you only go one at a time, never more than once. If you have any questions, just roll back. The cool thing is rolling back is compatible, so it's a safe way to go. And then you say, okay, now let's go figure out what happened. Maybe you manually clean up what you did and try something else. So.
I have one more question.
Sure.
Have you had any experience applying this to schemas for, say, like serialization of objects that are in message queues? Like if you had Kafka and you had a whole bunch of messages of one format, can you migrate it to new formats of messages?
Yes, but not with this approach. This is really more of a permanent data store than a messaging. For our schema upgrades on Kafka, because we had so much data changing in motion, we did everything through JSON, and I actually have special serializers that they know how to look into the JSON and say, oh, this is this version of the object. Let me convert that to a case class, and then we transform it to the latest version. And so I did that all manually because data was changing out from under us, and literally, in the topic, there was at one point, I think we had 4 different versions of a JSON object in the same topic. Now that we're stable, we're gonna move back to the Avro type schema where if you have the Confluent Kafka, they have the schema registry built in to the system. That's where we're going. I don't use this process though for Kafka specifically because it's kind of a different beast in that it's not one schema upgrade. Your database doesn't change. Your database has multiple instances of itself. It's got multiple views of what it thinks is right at the same time.
I was just wondering if you could do something like
Yeah. I was actually at a company that was featured here. I won't give out the name. It's featured downstairs in one of the keynotes. And they actually did it both ways. We did a topic per version. Does the word nightmare mean anything to you? It was just like, I literally was like, who's got my data when, where? You know, and like, okay, we're running, where'd my data go? Why'd all of a sudden stop processing? Oh, it's over on that topic. Oh, crap. Okay, now let's restart the app on that topic, type stuff. And then we finally moved over to getting the schema registry, which is literally, I mean, all you do is you put a binary 4 bytes on the front of your message, which tells you which version of the schema you're expecting. And, you know, that we migrated to that and all our problems solved. So that probably answers your question of what I think, because I'm not going back there. Yeah. So, any more questions? Okay. Cool. Are we done? All right. Well, thank you very much. Thanks.